Welcome back to the channel. Today, we're diving into one of the most critical and fascinating components of a large two-stroke marine diesel engine. In this episode, we're dissecting one of the most sophisticated components found in modern two-stroke marine diesel engines: the electronically controlled exhaust valve system of the MAN B&W ME series engine. This isn't your grandfather's cam-driven setup. This system replaces mechanical cams with electronic brains and hydraulic muscles, giving engineers unprecedented control over valve timing, fuel economy, emissions, and reliability. Section 1. Construction Overview. The ME engine's exhaust valve system is based on a cage-type exhaust valve, allowing removal and maintenance without disturbing the cylinder cover. Let's break down the components. Valve casing or housing. Constructed from high-strength alloy cast iron or steel. Integrated cooling passages allow freshwater circulation to maintain thermal stability even under exhaust gas temperatures exceeding 500 to 600 degrees Celsius. Provides the structural mount for the valve spindle, actuator, and air spring assembly. Valve spindle and valve disc head. The spindle is a vertically moving shaft made from pneumatic alloys or chromium-molybdenum steels, chosen for their high-temperature creep and fatigue resistance. The valve disc, seating against the valve seat, is hard-faced with stellite. To withstand hot corrosion, erosion from gas flow, and to ensure long-term seating integrity. The transition between spindle and disc is designed to minimize thermal gradients and mechanical stress concentrations. Valve rotator, the wing bush. Mounted on the spindle is a winged rotator or vane-type rotator. It uses the kinetic energy of high-velocity exhaust gases to slowly rotate the valve during each cycle. This uniform rotation distributes heat evenly across the valve seat, minimizes asymmetric wear, prevents carbon buildup at localized zones. Result: extended operational life and reduced overhaul frequency. Valve seat ring. This is a replaceable insert, generally of molybdenum steel, stellite-coated, machined to micron-level tolerances, ensuring a gas-tight seal when the valve is closed. In some models, cooling bores are integrated for conductive heat transfer from the valve disc. Section 2. Hydraulic actuation via LVA and HCU. Now, the core of ME engine innovation. Electronically controlled, hydraulically operated valve actuation. Unlike MC series engines that use mechanical cams, ME engines use a hydraulic cylinder unit, HCU, which combines electronic valve actuator called ELV, high-pressure hydraulic supply, 200 bar, hydraulic actuator piston for mechanical movement. How it works: the engine control system, ECS, sends a digital signal to the ELVA valve, which is a proportional valve. ELVA meters high-pressure hydraulic oil into the actuator chamber. The actuator piston moves downward, pushing the valve spindle and opening the exhaust valve. Once the command ends, ELVA closes, and return oil drains back to the system. This actuation system allows fully customizable valve timing, real-time load-dependent adjustments, improved fuel economy, and reduced NO and SO emissions. Section 3. Pneumatic valve closing, the air spring system. Instead of a mechanical spring, the ME exhaust valve uses a pneumatic air spring system. Located below the valve actuator, the air spring chamber is charged with compressed air at 7 bar. When hydraulic pressure is relieved, the compressed air expands, forcing the valve closed. A small quantity of lubricating oil in the airstream lubricates the valve guide, seals the guide stem clearance, prevents exhaust gas blowby. This design ensures consistent closing force, reduced spring wear, and aiding overall valve guide longevity. Section 5. Advantages over cam-driven systems. No camshaft for exhaust. Reduces mechanical complexity and maintenance. Variable timing. Allows for load-dependent timing optimization, improving scavenging, reducing SFOC, specific fuel oil consumption, and enhancing combustion. Lower NO and smoke emissions. Precise control improves combustion and exhaust management. Reduced mechanical wear. Fewer moving parts, less stress. Valve rotation and smooth actuation prolong lifespan. Remote diagnostics and real-time tuning. ECS interfaces enable shore-based control centers to monitor, adjust, and optimize the exhaust valve performance remotely. Summary. The ME engine exhaust valve system represents a giant leap in diesel engine engineering, replacing mechanical cams with digitally timed hydraulic actuation and air-driven closure. It's a smart, responsive, and durable solution for modern marine propulsion, balancing performance with efficiency and emissions compliance. If you're a marine engineer, cadet, or a student preparing for your orals, this is the kind of system you need to understand inside out. Hit subscribe for more in-depth breakdowns of engine systems, control mechanisms, and marine technology. Comment below with your questions, or the next topic you want us to explore. Until next time, keep the engines running efficiently.